All right, 1-3. Sorry for the little edit here, but this is just supposed to be 1-3. Okay, we're going to learn about factoring, and we're going to use the quadratic formula to solve quadratics. But something you got to remember about factoring is that after you multiply two binomials together, what factoring is trying to undo the multiplication. So you've multiplied them together, now you're trying to go backwards. That's what factoring is. So you have to remember that C is a product of the two factors, and B is a sum of the two factors. Let me show you what I mean as an example. Like, let's just take this simple polynomial x plus 1 and x plus 2. And if I was to multiply these together, we could do the box method. I'd get x squared, 1x, 2x, and then 1 times 2 is 2. So if I was to write this all out, it'd be without adding, I'd have x squared plus 1x plus 2x plus 2. And then I would add these like terms together, and I'd have x squared plus 2x. No, 1 plus 2 is not 2. X squared plus 3x plus 2. What I want you to recognize is that this 3 is really just adding these two numbers together. So if I just add these two numbers together, I already know what this middle term is going to be. Also, if I was to just multiply 1 and 2, that's how I'm going to get this last number. It's a general rule. It helps you be able to factor things quickly. Okay, I'm going to also teach you something that I call the star method that helps you organize this material. And so in order to do the star method, I'm going to draw it up here for you. I want you to always put your C on top. You're going to look for something that multiplies up to C. Put your B on bottom. You're going to look for something that adds up to B. Let me give you a couple examples so you can see what I mean on how to do this. And once you get this down, I think factoring will be a breeze. So this first example here, I have x squared minus 8x plus 15. I'm going to make my little star. I'm going to put my C value, which is 15 up top, my B value, which is negative 8. Now, I need to figure out two numbers that multiply up to 15 and add up to negative 8. And they have to do both. It can't just be one or the other. It has to do both perfectly in order for it to be factorable. So what are these two numbers? Well, I think the two numbers are negative 3 and negative 5. So negative 3 times negative 5 is positive 15. Negative 3 and negative 5, when you add them together, makes negative 8. Therefore, I could write my factors as x minus 3, x minus 5. And a good practice is to actually, until you're really good at this, is actually multiply these back together with the box method. And if you multiply these back together, you should end up with the original. That's how you could just check your work. So that's a good practice to get in the habit of. But that's it. So you're just going to find two numbers that multiply up to the top and add up to the bottom. I say that's it, but this is a simple one. And anytime your A value is 1, it's a lot simpler. All right, we're going to see how when the A value is something other than 1, we're going to have a couple more steps. But when the A value is 1, it's very, very simple. So let's take a look at number 2. All right, number 2, make my little x. So I'm going to put the 16 up top. I'm going to put the 8 on bottom. And I'm trying to find two numbers that multiply up to 16 and add up to 8. Now, if for whatever reason you get stuck, what I like to do is just start listing numbers that I know multiply up to the top number. So start with 1, 1 times 16, 2 times 8, 3 doesn't go into it, 4 times 4. As soon as you get two numbers that are the same or two numbers really close to each other, you're done and you found all your possible matches. So now, out of these sets, which one of these adds up to 8? Well, it's 4 times 4. So we're going to go ahead and put a 4 here and a 4 here. That means your factors are x plus 4 and x plus 4. You could also write it as x plus 4 in parentheses squared. And we have factored that completely. All right, what I want you to do on the video is go ahead and try numbers 3 and 4 on your own. And then, of course, unpause it when you're ready to check your work. All right, so for number 3, you put the negative 10 up here, the negative 9 down here. This is often tricky. When they're really close to each other, you want to think about it's 1 and that same number, that same C value, because that'll happen a lot, and a lot of times students get confused, like what multiplies up to 10? They think they're looking for a 2 and a 5, but that doesn't add up to 9. So just know sometimes it's just the number itself and 1. because negative 10 times 1 makes negative 10, and negative 10 plus 1 makes negative 9, and so these are your factors, and so you just write it as your factor, and you're good to go. Over here, you should have put 6 on top, negative 5 on the bottom. You need something that multiplies up to 6, positive 6, so you actually can do two negatives. Negative 3 times negative 2 makes positive 6. Add them together, you get negative 5, and there you have it factored. Okay, I'm going to skip this method called BFD. It stands for borrow, factor, divide. But I'm going to skip this. If you're really interested, you guys could ask me about it in class. But I think this other way is a lot more efficient. And it'll just be a lot easier for you to get it down. Because we're going to take this problem and we're going to do the star method. But notice now we have something slightly different. The A value is 2. And so to do these types of problems, I call it the advanced star method. So I'm still going to make this little x, but now I'm going to add another line right here. And now on the top, I'm going to do A times C and put the B down here. And if you think about this, you already were doing this. You just didn't realize you were doing it because up here, the A value is always 1. Well, 1 times 15 is 15. 1 times negative 10 is negative 10. And 1 times 16 is 16. And 1 times 6 is 6. So you were doing that the whole time, you just didn't have to think about it. Now you have to think about it when the A value isn't 1. And so you put A times C on top. Again, we want something multiplies up to that, something adds up to that. And you're going to have to put your A's on bottom. And what's going to happen is we're going to get little fractions here. And I'll show you what we can do with those in a little bit. So let's try this with our problem. I got A times C, so 2 times 21 is 42. Put that on top. I have 17, put that on bottom. And whatever my A value is, I'm going to put it on the bottom part of these fractions. So I'm going to have a 2 here and a 2 here. And now I need something that multiplies up to 42 but adds up to 17. Again, I don't know it right off the top of my head, so I'm just going to start making a list of numbers that multiply up to 42 until I get there. I think 3 times 14 will work, and I think that's our magic too. So I'm going to put a 3 here, 14 here. It doesn't matter which side you put them on. You can put the 14 here, the 3 here. Doesn't matter. All right, now here's the thing you have to do with the star method. After you do the star, there's 2 things you got to do. You got to reduce, and then you have to do what I call bottoms up. Sounds silly, but that's what you got to do. So 3 over 2 doesn't reduce, so then we do bottoms up. What I mean by that is the number on the bottom is going to come up and become your coefficient. Let me show you what that looks like. 2x plus 3. See how this number that was on bottom became, we put it up in front as a coefficient? That's what we do. Now this number on the right, 14 divided by 2, that does reduce. That reduces just a nice neat 7. And so that means my other factor is just x plus 7. And boom, you're done. This, I think, is the simplest way to factor once you get it down. I know it's a little bit of a mess. You got to make this little star, put all the numbers in the right spot. But once you do this, it makes factoring really simple. And it's going to come in really handy when we go to solve, which you'll see later on in this video. All right, let's go ahead and turn to the next page. See some more problems. I'm going to show you how to factor by grouping, and really this is the same process, but this is kind of what's happening behind the scenes of the star method, so you know like the actual math that's taking place. So let's take a look at this first problem, example number 1. We're going to do it by grouping, but we still need to do our little star where we put the 15 on top and the 8 on the bottom, because we still need our magic numbers. We still need to know what multiplies up to 15 and adds up to 8. And hopefully you see it, it'd be 3 and 5, because 3 times 5 is 15, 3 plus 5 is 8. All that really is doing is telling us how to break this 8 right here up. So we know we have an x squared, and we know we have a plus 15 over here, but we want to break this 8 up into 2 parts that add up to this b term. So in this situation, we found 3 and 5, so we know we have 3x plus 5x. That's how we know to break it up, okay? this little star method tells us what these numbers are. If I did a 2 and a 6 here, yeah, it would add up to 8, but it wouldn't factor nicely, which is the whole point of this. And now what we're going to do is we're going to group it. We're going to group it, and we're going to take out the greatest common factor of each term, or of each side. So what we have here is we have an x squared plus 3x. Well, we could take an x out of both of these. If I take an x out of both of these, I would have an x plus 3 left. We're still grouping this. We're still keeping them separated for now. Over here on the right, the greatest common factor is 5, because I could take a 5 out of both of these terms. If I do that, I'd have plus 5, and then I'd have x plus 3. If you did this right, these will be exactly the same. They will always be exactly the same. And now you get to do something that looks kind of magical in math, but it's really simple. It's a simple idea. If you have an x plus 3 here and you have an x plus 3 here, then these are like common factors of these two expressions. And so you can just kind of pull that out. You can take out that factor of x plus 3. And what would be left? Well, you'd have an x and a plus 5. So then to the right, you would write x plus 5. That is how factoring by grouping works. Now, you can see that's a lot of steps. That's a lot of steps. So that's why I would prefer to just use the star method and then take my values, my 3 and my 5, and just go ahead and say, well, I already know it's going to be x plus 3 times x plus 5, and I'm done. But the reason why I want to show you this is I want you to understand what's actually happening when you factor. And this is what's actually happening, is that you're finding these perfect numbers that when you take out the greatest common factor, the GCF, it'll factor down beautifully to these two binomials. But I think the shortcut just is a lot quicker. And if you're doing a problem on Khan Academy and you look at the hints, they are going to explain it by grouping. They're not going to explain it how I did. So they're not going to explain it with my shortcut. So they're going to explain it by grouping, because this is like the real math and this is like a shortcut. So let's take this same principle to this next example. We still have to do the thing where we multiply these a and c together. So 5 times 15 is 75. And we have to put the negative 22 on bottom. And we still want to find these magic two numbers that multiply up to 75 and add up to negative 22. And if you just start listing your numbers, you got 1 and 75. 2 doesn't go into it. 3 and 25. And you can see right away, I think I can get to negative 22 if we just make the 25 negative. So those are your magic two numbers. You can keep making the lists, but usually once I find my pair, I like to just stop from there. Okay, remember though, for this method, all we're doing with these two numbers is looking at how to split up this negative 22. And it shouldn't matter how you split it up, whether you put the 3 first or the negative 25 first. It shouldn't matter. So let's just go ahead and put the 3 first. I'd have 3x minus 25x, and then minus 15. And remember, if you combine these two terms, it should go back to that middle term. And sure enough, 3 minus 25 is negative 22. Okay, now I'm going to group them, and I'm going to look for the greatest common factor on each side. Well, on this side, the only greatest common factor is just x. So once again, I'm just going to take an x out. It would leave me with 5x plus 3. On this side, the greatest common factor is actually negative 5, because they both have a negative. Remember, the negative could be a factor, so just like negative 1 sometimes is your greatest common factor. But in this situation, it's negative 5. So let's pull a negative 5 out. What would I have left? Well, here I would have positive 5x. And negative 15, take out a negative 5 is positive 3. Remember, if we did it right, these two binomials should be exactly the same. So I can factor that out. If I take out a 5x plus 3 from both of these, right, what would I have left? I'd have an x minus 5. And there's my factoring. That's factoring by grouping. Again, I think it's much easier. Let's go check out my star method now that we've already done it the long way. If I would have just put a 5 here and a 5 here, and I would have had to find these same two numbers. The same numbers that I have up here, I'd have to find here. So let's just put in, I already found them. It was 3 and negative 25. that doesn't reduce, so I do bottoms up, I'd get 5x plus 3. Negative 25 over 5 does reduce to negative 5. And so I get another factor of x minus 5, and I'm done. So that's why I like my star method. I think it just is a lot smoother. All right, why do we want to factor? Well, sometimes we just need to factor, but other times we need to solve. So let's take a look at these problems here. We're going to factor, and we're going to solve the equation. Before we can do anything, step one is always set equal to 0. You have to set equal to 0 before we can solve these. So let's take a look at this guy. It is not equal to 0, but that's okay. We can easily just add a 6 to both sides, and I get a new equation that says x squared minus 5x plus 6 equals 0. I'm going to do star method, and I'm going to see something that multiplies up to 6 and adds up to negative 5. How about negative 2 and negative 3? And I can go ahead and write my factor. I could say x minus 2 times x minus 3 equals 0. Now, this is where there's something important here that you have to know that you've probably seen before. And if you don't know it, maybe write it down. This is something called the zero product property. And because of the zero product property, we can do lots of things. Remember, if I did 0 times A, that would equal 0. And if I did B times 0, that would also equal 0. And so since we know that this equals 0, what we're allowed to do is we're just allowed to assume that these individual factors are both 0. So we can just say, let's just split this. We could say x minus 2 equals 0, x minus 3 equals 0, and solve each of these. I'd have add 2, I'd get x equals 2, add 3, I'd get x equals 3. And so it turns out our solutions are 2 and 3. Well, here's the beauty of the star method that I was hinting at before. I got negative 2 and negative 3 from my star. My solutions will always be the exact opposite of the factors. Solutions, opposite of my factors. That will always be the case. So on example number 4, I'm going to kind of start you off on how I would start it, and then let you finish it and see if you can just assume what the answers will be just from the star method. Remember, it's the advanced star method, so you're going to have to reduce them, but I think once you get those numbers, you'll find the answers pretty quickly. So let's start it off. Let's get the advanced star method set up here. Oh, we have to get it set equal to 0 first, so it's not. So let's subtract 5 from both sides. So I'd have 8x squared plus 18x minus 5 equals 0. And 8 times negative 5 is negative 40. Positive 18 goes here, and I have to put an 8 here and an 8 here. What I need to do is find something that multiplies up to negative 40 and adds up to 18, and then I'll reduce. So I'm going to let you guys go from there. Think about the numbers that multiply up to negative 40 and add up to 18. Once you get them, remember, your factors, after you reduce them, all you have to do is change the signs and you have your answers. So I'll let you play with that idea, see if you could figure it out, and then unpause the video when you're ready to check your work. Okay, so the numbers I found that both multiply up to negative 40 and positive 18 is negative 2 and 20. By the way, there will always only be one pair. There's not like there's two possibilities that can go here. There will always only be one. So negative 2 times 20 is negative 40. Negative 2 plus 20 is positive 18. You need to reduce these before you move on. Negative 2 over 8 reduces to negative 1/4. 20 over 8 reduces to 5 halves. Now, because you can take a 4 out of both of these. Here's the deal. I did all this work over here to prove what the answer was. And that work is correct and it's good, but I don't have to do that. All I have to do is take my factor and change the sign. Boom. And I have my answers. I don't have to keep going and do all this math every single time. It will always be the case, if you do the star method correctly, it will always be the case that these factors are the exact opposites of your solutions, and you're good to go. One caveat of that, just so you keep this in the back of your mind, that can't be negative. The A value cannot be negative. So A can't be negative. But that's not really a big deal. If you think about it, even if it was negative, you have it equal to 0, just multiply everything by -1, and it would change all these signs, and you'll be good to go from there. But just know the a value can't be negative. Keep that in the back of your mind, right? In order to use the star method to solve, the a value can't be negative. All right, let's keep going. Okay, we're going to do a little bit of review with the quadratic formula. I got the formula up here, and then I have Miss V's easy way. I want to talk about this a little bit. Miss V is Miss Velasquez, a teacher I used to work with, and this was her step-by-steps on how to make quadratic formulas simple. And I'm going to do it this way. I think it works. If you're confident in using a formula, that's fine. You can go ahead and just use the formula, but I just want to show you this way that is pretty foolproof. So the first step you do is you always find the discriminant. So let's do that for example 1. The discriminant is just the part that's b squared minus 4ac. And hopefully you remember, right? This is all based off of this equation in this format. So your b here is -3 in parentheses squared minus 4. Every time you plug in a value to an equation, you should be using parentheses. Your a is 1 and your c is -3. All right. So let's work this out. -3 squared is +9. And this is where a lot of students make a mistake. I can see that I'm going to do a negative times another negative, which means this is going to turn into a plus, not minus. It's plus. 4 times 1 times 3 is 12. 9 plus 12 is 21. Okay, so I've got the discriminant. What does it say to do next? It says place your answer under a radical sign and simplify. So underneath the square root, and I'm going to simplify. Well, there is no simplifying square root 21. It's already simplified. But what I mean by simplify is pull out all the perfect squares and factor it down. So next step, in front of the radical, place the opposite of the b value and plus or minus. So your b value is -3. The opposite of that is +3. So we're going to write 3 plus or minus square root 21, and then put that over 2 times your a. Your a is just 1, so 1 times 2 is 2. This doesn't simplify, so we are done. That's it. That's our answer. Probably should put an x equals here so we know what we're talking about. But that's it. I know it looks weird, but that's as simplified as we can get. I mean, you could plug this into a calculator and get a decimal answer, but this is the best exact answer we could come up with. All right, let's talk about number 2. Let's do the same thing. So on number 2, I'm going to do the discriminant first, b squared minus 4ac. The b is 1 and the a is 1. So I get 1 squared minus 4 times 1 times 5. That's 1 minus 20, which is -19. Here's the deal. There are no real solutions. Anytime your discriminant is, actually I should say, anytime your discriminant is less than 0, there are no solutions. No real solutions, to be specific. We could get imaginaries. Okay, no real solutions, so we're just going to say we're done. There's nothing else we can really do here. Unless they're asking for complex numbers, we are done. Okay. I want you to try 3 and 4 on your own. Again, pause the video and then unpause it when you're ready to check your work. Okay, let's give a rundown on these 2 problems. I did the discriminant first, worked it out, I got to 80. But see, the square root of 80 can be simplified because there's perfect squares that are a factor of 80. So I could break that down to 16 times 5, and the square root of 16 is 4. So I'm going to write it as 4 square root 5. Plus or minus, I'm going to put in the opposite of b, which is -8, and then 2 times your a, which is +8. And then you can take a 4 out of each of these terms. You have to take it out of every single term in order to reduce. You can't just do the front ones. So when you do that, you end up with -2 plus or minus square root 5 over 2. See, the instinct here might be like, oh, I could cancel out these 2's. But you cannot, because in order to cancel out these 2's, you'd have to take a 2 out of this term. And there is no 2 in here, so you can't do that. All right, over here on number 4, I'm going to do the discriminant part first. And I plug it all in, I get 49. The square root of 49 is a nice, neat 7. So I'm going to do 7. I have -3 plus or minus 7 all over 2 times my a, which the a is just 1, so I get 2. When you have a value like this that doesn't have a square root, you can actually just simplify it down, break it up, do 1 minus and 1 plus. See how you're allowed to just do 1 each way. And then you will do -3 minus 7, which is -10. -10 divided by 2 is -5. And then -3 plus 7 is 4. And obviously 4 divided by 2 is 2. And there you have your two actual nice, neat answers, -5 and 2. All right, folks, that's it. See you all in the next video.